Question 1. For each statement below, indicate whether the answer is true or false. Asking the model to act as a persona can tailor perspective and tone to a business role. The correct answer is true. Requesting the model to suggest better questions can reduce the number of iterations to reach a precise answer. The correct answer is true. Providing a template for output format can improve consistency of structure. The correct answer is true. Adding reflection requires retraining the model to enable step-by-step reasoning. The correct answer is false. I am now going to explain each of these answers so you can clearly understand why they are correct. To begin with, acting as a persona is true because when you assign a model a specific role, such as a business analyst or marketing expert, it naturally adjusts its style, tone, and perspective. Consequently, the responses align more closely with the needs of that role, much like how a consultant changes communication depending on the client. Furthermore, the second statement is also true, since asking the model to propose better questions often sharpens the direction of the conversation. As a result, the model can get to an accurate solution faster, similar to how a doctor asks clarifying questions to diagnose a patient efficiently. Additionally, the third statement is true, because templates bring structure. When you provide headings or fields, the model follows them, producing consistent and predictable responses, just as forms ensure uniformity in professional reporting. Finally, the fourth statement is false, because reflection does not require retraining. Instead, you can simply prompt the model to think step by step, reflect, or reconsider its reasoning, much like asking a student to double-check their work without teaching them an entirely new skill set. Question 2. Fill in the blanks by selecting the correct options from the drop-down menus. To improve answers without retraining, developers often start with prompt engineering to set behavior and structure, then add RAG when the application needs up-to-date or domain-specific context. I am now going to explain these choices so you fully understand why they fit the sentence correctly. First, prompt engineering is the right starting point, because it allows developers to guide the model's tone, structure, and reasoning simply through instructions, meaning no retraining is required. For instance, a customer support team can craft prompts that make the model respond politely and concisely without touching the model's underlying weights. Moreover, once behavior is set, RAG becomes useful whenever the application must access fresh information or specialized documents. This is particularly important when the built-in knowledge is outdated, such as retrieving medical guidelines, legal updates, or internal company documents. Consequently, RAG fills the knowledge gaps by allowing the model to reference external sources in real time, which makes it the correct second choice in the sentence. Question 3. Fill in the blanks by selecting the correct options from the drop-down menus. After creating an AI project client, obtain a chat client with GetOpenAI client. Then set the API version to 2024-1021. Next, send a chat completion by calling chat.completions.create with the model set to the deployment name and messages set to system and user messages. Finally, print response.choices0, message.content. I am now going to walk you through why each of these answers is correct, so the entire flow becomes clear. First, GetOpenAI client is the right method because it retrieves the authenticated chat client required to communicate with the API. Without this, no chat completion call can be made. Moreover, the API version 2024-1021 fits the structure expected in the example and ensures compatibility with the features used. Additionally, chat.completions.create is the correct call because it is the exact method used to generate a chat completion within this API pattern, much like making a function call in a programming library to trigger a specific action. Furthermore, the model parameter expects the deployment name rather than a model ID, which aligns with how Azure-style deployments work. Finally, response.choices0, message.content is the correct accessor because it points directly to the assistant's generated text, similar to checking the first item in a list to retrieve the returned message. Question 4. For each SDK element or parameter, drag it to the universally correct description. returns an authenticated OpenAI chat client scoped to the project's Azure AI Foundry resource, is matched with project client.getOpenAI client, API version equals 2024-1021, selects which deployed model to use by its deployment name is matched with model equals your model deployment name, provides system-level instructions that guide assistant behavior is matched with role, system, content, you are a helpful AI assistant, supplies end-user input that the model should answer is matched with role, user, content, user prompt, retrieves the text content of the first returned chat message is matched with response.choices0message.content. I am now going to explain why each option matches its description, so the structure becomes completely clear. First, project client.getOpenAI client, API version equals 2024-1021 is correct, because this method creates an authenticated chat client specifically tied to the project's Azure AI Foundry resource, meaning all subsequent requests are routed through the proper configuration. Similarly, model your model deployment name is the right match because the model parameter expects a deployment name, not a raw model ID, ensuring the request is directed to the intended deployed model. Furthermore, the system message role, system, content, you are a helpful AI assistant, sets the assistant's persona and conversational rules, much like giving a worker a job description before they begin. Additionally, role user, content, user prompt correctly represents the user's input since it captures what the user wants the model to respond to. Finally, response.choices0, message.content is the accurate match for retrieving the generated output because it accesses the first assistant message returned in the completion, similar to reading the first line of a printed response. Question 5. For each artifact or activity, drag it to its universally true description. A service-level document outlining model or service limitations is matched with transparency note. A model-level document summarizing capabilities, data, and known limitations is matched with model system card. A structured process and template to record potential harms is matched with responsible AI impact assessment guide and template. Deliberate probing to surface harmful outputs or vulnerabilities is matched with red team testing. I am now going to explain why each match is correct so the distinctions between these artifacts become clear. To begin with, a transparency note is the correct match for the service level description because it explains how a service behaves, what its limitations are, and what users should consider for responsible use. This is similar to how a product manual highlights constraints and safety notes. Moreover, a model system card fits the second description since it provides details about a specific model, including its training data, strengths, and known weaknesses, much like a specification sheet for a technical component. Additionally, the Responsible AI Impact Assessment Guide and template is the right match for documenting potential harms because it gives teams a structured way to assess risks before deployment. Finally, red team testing aligns with deliberate probing because it involves intentionally challenging the system to uncover possible failure points or harmful behaviors, similar to stress testing security systems to identify vulnerabilities. Question 6. A developer needs a single Python package that enables connecting to an AI project and accessing its resource connections, agents, and models through code. Select one answer: A, Azure AI Projects for JavaScript; B, Azure AI Projects; C, Azure AI Projects for Microsoft.NET; D, Azure AI Services APIs Endpoint. The correct answer is B, Azure AI Projects. I am now going to explain why this is the right choice, so the reasoning becomes completely clear. First, Azure AI Projects is the official Python package designed specifically for connecting to an AI project and interacting with its resources. It allows developers to manage agents, models, and connections directly through Python, making it the only option that satisfies the requirement. Furthermore, the JavaScript and .NET versions listed in options A and C are for different programming languages, so they cannot serve as the Python solution. Additionally, option D refers to an endpoint type rather than an installable package, meaning it does not provide the SDK features needed to work with project-based resources. Consequently, Azure AI Projects stands as the correct and only appropriate answer for Python development. Question 7. Arrange the following steps involved in the RAG pattern in the correct order. Retrieve grounding data based on the user's initial prompt. Augment the prompt with the retrieved grounding data. Use a language model to generate a grounded response. I am now going to explain why this sequence is the correct one, so you clearly understand how the RAG process flows. First, the system must retrieve grounding data based on the initial prompt because the model needs accurate and context-rich information before anything else happens. This retrieval ensures the answer is tied to relevant and factual data rather than general training knowledge. Afterwards, the retrieved information is added to or used to augment the prompt, so the model can incorporate those facts directly into its reasoning. Finally, once the prompt has been enriched, the language model can generate a grounded response that reflects both the user's question and the retrieved supporting information. Question 8. A team has a prioritized list of potential harms and is preparing inputs for the first measurement run. Which approach best aligns with measurement guidance? Select one answer. A. Use prompts designed to reflect each harm based on realistic usage and varied phrasing. B. Use a broad set of prompts unrelated to specific harms for general coverage. C. Avoid prompts that might trigger harmful content during testing. D. Update harm categories mid-process to speed up evaluation. The correct answer is A. Use prompts designed to reflect each harm based on realistic usage and varied phrasing. I am now going to explain why this approach is the one that aligns with proper measurement guidance. First, testing must be targeted toward the specific harms identified during the planning phase, which means prompts should be crafted to surface those risks directly. By using realistic phrasing and varied wording, the team ensures the model is evaluated in conditions that mirror real-world usage rather than artificial test cases. Meanwhile, broad unrelated prompts, as in option B, fail to uncover the prioritized harms effectively. Additionally, avoiding harmful prompts, as stated in option C, would prevent the team from detecting and accurately measuring real risks. Lastly, updating harm categories mid-process, as described in option D, introduces inconsistency that weakens comparability across runs. Consequently, option A is the only approach aligned with responsible and accurate harm measurement. Question 9. In Azure AI Resources, which statement correctly describes how built-in content safety analysis is applied? Select one answer. A. Only generated outputs are analyzed. B. Only user inputs are analyzed. C. Both user inputs and generated outputs can be analyzed. D. Neither inputs nor outputs are analyzed automatically. The correct answer is C. Both user inputs and generated outputs can be analyzed. I am now going to explain why this is the correct choice, so the safety workflow becomes easy to understand. First, Azure's built-in content safety features are designed to evaluate both the prompt that comes in from the user and the response generated by the model. This dual analysis ensures that harmful, policy-sensitive, or attack-like content is caught whether it appears before or after generation. Additionally, analyzing only outputs, as in option A, would miss harmful inputs that could manipulate or exploit the model. Likewise, analyzing only user inputs, as in option B, would leave harmful or unsafe model responses unchecked. Finally, option D is incorrect because Azure AI performs automatic content safety evaluation without requiring manual screening. Consequently, option C captures the full and accurate safety process. Question 10. For each statement below, indicate whether the answer is true or false. Preparing diverse test prompts should include edge cases and failure points. The correct answer is true. After testing a model, you can evaluate prompt flows either manually or automatically. The correct answer is true. Thumbs up or down ratings are purely cosmetic and should not influence iteration. The correct answer is false. Chat playground iteration can include tweaking the system message as well as the prompt. The correct answer is true. I am now going to explain why each of these answers is correct, so the reasoning behind them becomes completely clear. First, Preparing diverse test prompts must include edge cases and failure points, because these scenarios expose weaknesses that normal prompts often miss, much like stress testing a product before release. Additionally, evaluating prompt flows manually or automatically is true since both approaches are supported and help validate how different steps or orchestration behave beyond individual model calls. Furthermore, the statement about thumbs up or down ratings being purely cosmetic is false, because aggregated ratings help guide improvements to prompts, system messages, or even model parameters, meaning they directly influence iteration. Finally, the statement about tweaking both the system message and the prompt is true, because the chat playground allows adjustments to both elements, enabling deeper experimentation and refinement during development. Question 11. Which two statements are accurate about Azure AI multi-service resources? Select two answers. A. They always include Azure Kubernetes Service as part of the resource bundle. B. They eliminate the need for provisioning any Azure subscription resources. C. They group several AI services under one resource endpoint, simplifying management. D. They can reduce complexity for applications that use multiple AI capabilities. The correct answers are C. They group several AI services under one resource endpoint, simplifying management, and D. They can reduce complexity for applications that use multiple AI capabilities. I am now going to explain why these two statements are correct, so the purpose of multi-service resources becomes clearer. First, multi-service resources bring several AI services together under one endpoint, which makes management easier because developers no longer need to configure and maintain separate endpoints for each capability. This consolidation streamlines both integration and maintenance. Additionally, they reduce complexity for applications that rely on multiple AI features, since everything is accessible within a single resource, allowing teams to build systems more efficiently. Meanwhile, option A is incorrect, because Azure Kubernetes Service is not part of multi-service resources at all. Furthermore, option B is incorrect because all Azure services still require provisioning within a subscription, including multi-service AI resources. Consequently, options C and D accurately describe how these resources simplify and streamline AI development. Question 12. Which items belong to the safety system layer of mitigations? Select three answers. A. Content filters that classify by severity. B. Abuse detection to flag automated misuse patterns. C. Alert notifications to enable rapid response to harmful behavior. D. Selecting a simpler classification model for small, specific inputs. The correct answers are A. Content filters that classify by severity. B. Abuse detection to flag automated misuse patterns. And C. Alert notifications to enable rapid response to harmful behavior. I'm now going to explain why these three belong to the safety system layer so the distinction becomes clear. First, content filters that classify by severity are a classic part of the safety system because they actively detect and categorize harmful or sensitive content before it reaches the user. Additionally, abuse detection systems belong in the same layer since they monitor patterns of misuse, such as automated attacks, ensuring the platform can intervene quickly when suspicious behavior appears. Furthermore, alert notifications are also part of the safety system because they trigger operational responses that allow teams to address harmful outputs or behaviors in real time. In contrast, selecting a simpler classification model, as mentioned in option D, belongs to the model layer rather than the safety system layer, since it deals with choosing the model architecture, not implementing safety mechanisms. Question 13. Your team wants to sanity check a model interactively in the Azure portal before running batch manual evaluations. The model hasn't been deployed yet. What's the correct next step? Select one answer. A. Deploy the model in Azure AI Foundry, then test it in the chat playground. B. Upload prompts to the manual evaluations feature without deploying. C. Evaluate the full prompt flow first and ignore model-only testing. D. Change UI colors to improve perceived quality, then test. The correct answer is A. Deploy the model in Azure AI Foundry, then test it in the chat playground. I am now going to explain why this is the correct next step, so the workflow becomes clear. First, the chat playground requires a deployed model in order to run interactive tests. Deployment makes the model available as an endpoint, allowing your team to quickly experiment with prompts, system messages, and model behavior before moving on to more structured evaluations. Meanwhile, uploading prompts without deploying as in option B won't work because manual evaluations focus on batch testing and cannot run interactive checks. Additionally, skipping model-only testing, as option C suggests, would remove an important step that helps detect early issues before full-flow evaluation. Finally, option D is irrelevant since changing UI colors has no impact on model function or evaluation quality. Consequently, deploying the model first is the essential step for interactive testing in the playground. Question 14. Fill in the blanks by selecting the correct options from the drop-down menus. By extending an AI agent with custom tools, organizations can reduce repetitive workload and deliver tailored functionality that fits their specific business processes. The correct answers are reduce repetitive workload and deliver tailored functionality. I am now going to explain why these two choices complete the statement accurately. First, custom tools help reduce repetitive workload because they automate tasks that would otherwise require repeated manual effort, freeing teams to focus on higher-value activities. This is one of the core benefits of extending AI agents with domain-specific capabilities. Additionally, custom tools deliver tailored functionality because they are designed to meet unique business needs that built-in tools may not address. This allows organizations to shape the agent's behavior around very specific processes or workflows. In contrast, the incorrect options, such as increasing manual processing, enforcing pricing changes, or removing built-in capabilities, do not align with the purpose or behavior of custom tools. Question 15. For each Azure MCP tool configuration or runtime signal, drag it to the appropriate description. Uniquely identifies a specific remote MCP server tool entry is matched with server label, specifies the endpoint the agent connects to for a remote MCP server is matched with server URL, restricts which tools from a remote MCP server may be invoked, is matched with allowed tools, provides API keys or OAuth tokens per run without persisting them, is matched with update headers, tool resources. Indicates a run is waiting for developer authorization to call a tool is matched with requires action status, contains the tool name and arguments awaiting approval, is matched with requires action details. I'm now going to explain why each match is correct, so you understand how these MCP elements function. First, server label is the correct identifier because it distinguishes one remote MCP server tool entry from another, ensuring the agent knows exactly which server setup it refers to. Additionally, server URL points to the full endpoint where the remote MCP server is hosted, allowing the agent to establish a connection. Furthermore, allowed tools serves as an allow list, limiting which server-side tools the agent is permitted to call, improving safety and control. The update headers setting is responsible for supplying authentication for the current run, such as API keys or OAuth tokens, without storing them beyond that execution. Meanwhile, requires action status signals that the model attempted to call a tool, but is waiting for explicit developer approval before continuing. Finally, requires action details contain the specific tool name and the arguments the model intends to pass, giving the developer the information needed to approve or reject the call. Question 16. For each statement below, indicate whether the answer is true or false. Tools allow the agent to use existing APIs and services it otherwise couldn't access. The correct answer is true. The framework calls tools automatically even if the function's purpose and parameters are not described. The correct answer is false. Built-in tools are available immediately and require no extra setup. The correct answer is true. With multiple tools, the framework orchestrates which function to call and can combine results. The correct answer is true. I am now going to explain why each statement is evaluated this way, so the behavior of tools in the framework becomes clearer. First, tools do indeed allow the agent to reach external APIs and services it normally cannot access, which is why the first statement is true. Tools effectively extend the agent's abilities. Additionally, the framework cannot call a tool automatically unless its inputs and purpose are clearly described. So the second statement is false because the model needs that description to invoke the tool correctly. Furthermore, built-in tools like Code Interpreter, File Search, and Web Search are ready for use without additional configuration, making the third statement true. Finally, when several tools are available, the framework can choose the right one based on the user's request and even combine the outputs when necessary. So the last statement is true. Question 17. Fill in the blanks by selecting the correct options from the drop-down menus. The concurrent builder class is used to create a workflow that runs multiple agents in parallel. I am now going to explain why these choices correctly complete the statement, so the purpose of Concurrent Builder becomes clear. First, Concurrent Builder is designed specifically to create a workflow, meaning it structures how different agents will operate within the execution plan. Additionally, it is built for concurrency, so the workflow it produces allows multiple agents to run at the same time, rather than waiting on one another. This parallel execution boosts efficiency and supports use cases where independent tasks can be processed simultaneously. In contrast, options involving sequential coordination, dependency chaining, or tool management do not describe the behavior of Concurrent Builder, which focuses purely on orchestrating parallel agent execution. Question 18. Fill in the blank by selecting the correct option from the drop-down menu. Magnetic orchestration emphasizes building and documenting the approach as much as delivering the final solution. I am now going to explain why this option correctly completes the statement, so the intent behind magnetic orchestration becomes clear. First, magnetic orchestration is designed to make the system's reasoning transparent by documenting its steps, plans, and decisions as it works. This means it values explanation and clarity just as much as producing the final answer. The approach isn't focused on runtime speed, nor is it simply about keeping logs. Instead, it prioritizes maintaining a clear record of how the solution is formed. Likewise, it doesn't try to minimize agent count, since the pattern supports using as many specialized agents as needed. Consequently, documenting the approach is the correct fit for the blank. Question 19. AI agents are designed to act not only on user prompts, but also on what other type of input? Select one answer. A. Random guesswork. B. Environmental factors they perceive. C. Direct hardware signals without processing. D. Only scheduled tasks set by administrators. The correct answer is B. Environmental factors they perceive. I am now going to explain why this is the right choice so the behavior of AI agents becomes clearer. First, AI agents adapt based on the environment around them, meaning they consider changing external conditions in addition to user prompts. This might include system status, contextual cues, or surrounding data that informs how they respond. Meanwhile, random guesswork, as in option A, is not how agents operate because they rely on grounded inputs, not randomness. Additionally, option C is incorrect because agents interpret information contextually rather than acting on raw hardware signals without processing. Finally, option D does not capture the full behavior of agents since they respond dynamically to environmental factors, not just scheduled tasks. Consequently, environmental factors they perceive is the correct and complete answer. Question 20. Arrange the following steps that describe how connected agents handle a user request in the correct order. Main agent receives and interprets the user's input. Main agent delegates tasks to subagents. Subagents perform their specialized functions. Results are combined to accomplish the overall task. I am now going to explain why this sequence represents the correct flow of connected agent collaboration. First, the process begins when the main agent receives and interprets the user's input, because understanding the request is essential before any action can be taken. Next, the main agent delegates tasks to the appropriate subagents, identifying which specialized components are best suited to handle each part. Afterwards, each subagent performs its specific function independently, using its particular expertise to complete its assigned piece of the task. Finally, the results from all subagents are combined, allowing the system to deliver a complete and coherent solution to the user. This ordered flow ensures clarity, modularity, and efficient teamwork across all agents involved. Question 21. A healthcare organization is developing an AI system that can analyze medical data, assist doctors, and send summarized reports to patients. They decide to allow the system to provide recommendations, but doctors must confirm them before they are applied. Which capability makes this design possible? Select one answer. A. Multi-region data replication. B. Autonomous-only decision engine. C. Automated deployment pipeline. D. Human-in-the-loop process. The correct answer is D. Human-in-the-loop process. I'm now going to explain why this is the correct capability for the scenario described. First, a human-in-the-loop process ensures that the AI system can generate recommendations, but a qualified human, such as a doctor, must validate and approve the decision before any action is taken. This is crucial in healthcare where safety, ethics, and judgment are essential. Meanwhile, multi-region data replication concerns availability and redundancy, not decision oversight. Additionally, an autonomous-only decision engine removes human involvement entirely, which directly conflicts with the requirement for doctor confirmation. Finally, an automated deployment pipeline relates to DevOps automation rather than clinical decision validation. Therefore, the human-in-the-loop process is the only capability that supports controlled, supervised decision-making in this medical context. Question 22. For each statement below, indicate whether the answer is true or false. Magentic orchestration emphasizes thorough planning, even if it sacrifices execution speed. The correct answer is true. The pattern is best for rapid, repetitive tasks with predictable results. The correct answer is false. Configuring stall and reset counts helps prevent endless loops during orchestration. The correct answer is true. The dynamic ledger records only the final output and not intermediate goals. The correct answer is false. I am now going to explain why each statement is evaluated as true or false, so the behavior of magentic orchestration becomes clearer. First, the focus on thorough planning and documentation makes the first statement true, because magentic orchestration prioritizes structured reasoning rather than raw execution speed. Additionally, the second statement is false, since this pattern is meant for complex adaptive tasks rather than predictable, repetitive ones. Furthermore, the third statement is true, because stall and reset counts prevent infinite loops by halting or restarting the process when progress stops. Finally, the fourth statement is false, because the dynamic ledger captures the entire chain of reasoning, including goals, sub-goals, and intermediate steps, not just the final result. Question 23. A customer support agent must provide real-time updates as it processes a user request, rather than waiting to send a single final response. Which capability should be implemented within its agent executor? Select one answer. A. Caching results until all tasks are complete. B. Streaming responses back through the communication channel. C. Delaying output until every agent completes its process. D. Returning results only after manual confirmation from the client. The correct answer is B. Streaming responses back through the communication channel. I'm now going to explain why this is the right capability for the scenario described. First, streaming responses allows the agent executor to send incremental updates as soon as they are available, enabling real-time feedback rather than forcing the user to wait for a fully completed result. This is essential for customer support scenarios where transparency and responsiveness matter. Meanwhile, caching all results until completion, as in option A, would block real-time communication entirely. Additionally, delaying output until every agent finishes, as in option C, prevents incremental updates and defeats the purpose of real-time support. Finally, requiring manual confirmation before returning any results, as described in option D, introduces unnecessary friction and does not support automated streaming. Consequently, streaming through the communication channel is the only capability that meets the requirement. Question 24. What is a key advantage of using the AI agent service for building agents compared to traditional AI development? Select one answer. A. It requires writing all models from scratch before use. B. It eliminates the need for extensive AI or machine learning expertise. C. It prevents the use of any external services or APIs. D. It mandates human supervision for every agent action. The correct answer is B. It eliminates the need for extensive AI or machine learning expertise. I am now going to explain why this option is the key advantage, so the benefit becomes clear. First, the AI agent service provides built-in capabilities, pre-configured tools, and extensible components that let teams create agents without having deep AI or ML knowledge. This helps organizations move faster and lower the barrier to entry for AI adoption. Meanwhile, option A is incorrect because the platform includes pre-built integrations, meaning you do not need to build models from scratch. Additionally, option C is wrong since external APIs can be used through custom tools. Finally, option D is incorrect because the service does not require human supervision for every action. It supports automation where appropriate. Consequently, eliminating the need for extensive AI expertise is the most accurate advantage. Question 25. Which statement best describes the provider flexibility supported by the Microsoft Agent Framework? Select one answer. A. It is limited to agents built only with Azure OpenAI. B. It supports multiple agent providers including Azure OpenAI, Microsoft Copilot Studio, and Anthropic. C. It can connect only to OpenAI and no other providers. D. It requires a separate SDK for every different agent provider. The correct answer is B. It supports multiple agent providers, including Azure OpenAI, Microsoft Copilot Studio, and Anthropic. I am now going to explain why this option correctly reflects the framework's design and capabilities. First, the Microsoft Agent Framework is intentionally built to be provider agnostic. This means it allows developers to integrate agents from various ecosystems under a unified interface, simplifying interoperability and reducing development overhead. Because of this design, it is not limited to Azure OpenAI, as suggested by option A, nor is it restricted only to OpenAI, as stated in option C. Similarly, option D is incorrect because the framework abstracts provider differences, eliminating the need for multiple separate SDKs. Consequently, supporting multiple agent providers is the most accurate description of its flexibility. Question 26. Which conditions make concurrent orchestration the best choice for a workflow? Select two answers. A. Tasks can run at the same time without dependency. B. Agents need to share and build on each other's results. C. The task benefits from different specialized skills working independently. D. The process requires a strict order of execution. Correct answers, A and C. I'm now going to explain why these two options are the right match for concurrent orchestration. To begin with, concurrent orchestration is designed for scenarios where multiple tasks can be executed in parallel, which is exactly why tasks that can run at the same time without dependency align perfectly with this pattern. Since no task relies on another to complete, the system can maximize efficiency by running them simultaneously. Furthermore, this orchestration model shines when different specialized skills need to be applied independently. Each agent can operate autonomously within its area of expertise, contributing its output without waiting for others, which significantly accelerates the overall workflow. Conversely, when tasks require agents to build on each other's results, the process becomes sequential by nature, making concurrent execution unsuitable. Additionally, any workflow that demands a strict order of execution inherently conflicts with the parallel design of concurrent orchestration. Question 27. Which two operations are typically implemented in an agent executor? Select two answers. Option A, execute. Option B, discover. Option C, stream. Option D, cancel. The correct answers are A, execute, and D, cancel. Now that we have read the question in all four options and identified the correct ones, let's move into the explanation. Firstly, an agent executor's main job is to run tasks on behalf of a client or another agent. Therefore, the execute operation is essential because it actually processes the request and returns a result. Secondly, long-running or ongoing tasks sometimes need to be stopped safely. Consequently, the cancel operation is typically implemented so that a caller can ask the executor to halt an in-progress execution when that is supported. However, Discover is about locating agents or skills in a registry and is not an execution control operation. Likewise, Stream represents a data flow pattern rather than a core agent executor API method. So in practice, execute and cancel are the two standard operations you expect to see on an agent executor interface. Question 28. For each sentiment analysis API field or rule, drag it to its correct description in the correct match column. Each item may be used once, more than once, or not at all. Specifies that sentiment analysis is being performed is matched with kind. Holds per document results, including sentiment and confidence scores, is matched with documents. Represents the sentiment classification for the overall document is matched with sentiment. Lists confidence scores for positive, neutral, and negative values is matched with confidence scores. Contains the model version used for the analysis is matched with model version. Holds results for sentence-level analysis is matched with sentences. I am now going to explain how each of these fields works together in a real sentiment analysis response. First, kind tells the system which operation is running, for example, sentiment analysis. So the service knows it should calculate opinions rather than key phrases or language detection. Next, Documents gathers the overall result for each input text. So if you send 3 customer reviews, you get 3 document entries with their sentiments and scores bundled there. Within each document, sentiment gives the main label, such as positive, neutral, negative, or mixed, summarizing the overall tone of that review. At the same time, confidence scores breaks this down numerically, for instance showing 0.95 positive and 0.02 negative, which helps you judge how certain the model is. Moreover, model version records which underlying model produced those scores, which is important when you compare results across time or audits. Finally, sentences stores sentence-level analysis. So in a long review like, "The product is great, but shipping was slow," you can see that one sentence is positive while another is negative, giving a much richer view of customer feedback. Question 29. Fill in the blanks by selecting the correct options from the drop-down menus. When submitting a classification request using the REST API, the header must include OCP APIM subscription-key, and the task kind field must specify either custom single-label classification or custom multi-label classification depending on the project type. I'm now going to explain why these selections are required. First, OCP APIM subscription key is the authentication key that allows the API to verify that the request is coming from an authorized user, similar to how a password unlocks access to a secure system. Without this header, the service will reject the request entirely. Next, the task kind must specify either custom single-label classification or custom multi-label classification, because the API needs to know what type of classification process to run. For example, predicting a single category like sports or finance requires the single label option, whereas tagging a document with multiple themes such as health, nutrition, and wellness requires the multi-label option. Finally, choosing the correct task kind ensures the model executes the right workflow for the project, preventing errors and producing accurate predictions. Question 30. Fill in the blanks by selecting the correct options from the drop-down menus. A speech synthesizer object is created by combining a speech config and an audio config, enabling applications to perform text-to-speech conversion through methods such as speak-text-async. I am now going to explain why these answers are correct. To begin with, the speech synthesizer is the SDK client responsible for handling text-to-speech operations, much like a controller that manages how text is transformed into spoken audio. However, it cannot function on its own because it needs connection details, which are provided by speech config. This configuration includes the key and region, allowing the service to authenticate and know which resource to use. Additionally, audio config defines where the synthesized audio will be sent, whether that is the default speaker, a file output, or a stream, ensuring that the audio has a clear destination. Finally, speak-text async is the method that performs the actual synthesis asynchronously, allowing applications to continue running smoothly while the speech is being generated, much like how a navigation app continues operating even while voice instructions are being prepared. Question 31. For each Azure AI Speech SDK component, drag it to its correct purpose in the correct match column. Each item may be used once, more than once, or not at all. Stores region and key for connecting to the speech resource. Speech translation config defines the language in which input speech is spoken and target translation languages. Speech translation config specifies the audio input source, such as microphone or audio file. Audio config acts as a client for calling the translation API. Translation recognizer calls the speech API asynchronously to process a single utterance. Recognize once async. Now, I'm going to explain how these answers fit together. To begin with, speech translation config appears twice because it manages all the core connection details, including the region, key, and even the languages used for translation. This makes it the central configuration object for translation workflows. Next, audio config is correct for the audio input option because it tells the system where the speech audio originates, whether from a microphone or a file. Without this, the speech SDK wouldn't know what audio stream to process. After that, translation recognizer is the right match for the translation client, since it communicates directly with Azure's translation service to interpret and convert spoken input. Finally, recognize once async is used for making a single asynchronous translation call, which is ideal when you only need one recognition result rather than continuous processing. Altogether, these components work together to form a complete translation pipeline, from connecting to the service, to receiving audio, to processing one-off translation results, enabling smooth and reliable speech translation in real applications. Question 32. Fill in the blanks by selecting the correct options from the drop-down menus. The Azure AI Foundry documentation provides information about available models through the model catalog and collections. Articles. Now I'm going to explain how these answers fit together. To start with, the model catalog is the central place where Azure AI Foundry lists all available AI models, including their capabilities and details. This makes it the primary resource for anyone trying to understand what models they can use in their projects. Meanwhile, collections group related models together, which helps users quickly discover models that serve similar purposes or belong to a shared theme. For example, vision models might appear together in a single collection, making exploration far easier. Altogether, these two documentation elements work hand in hand. The model catalog gives the full overview, while collections streamline discovery by organizing models into logical groups. This combination ensures users can navigate the platform efficiently and find exactly what they need without unnecessary searching. Question 33. A content moderation platform needs to automatically distinguish between multiple meanings of the same word, such as whether Amazon refers to a company or a river, and provide external references for each. Which feature of Azure AI language should be used? Select one answer. A. Entity linking. B. Sentiment analysis. C. Key phrase extraction. D. Language detection. The correct answer is A. Entity linking. Now I'm going to explain why that answer is correct. Entity linking is the only feature that can interpret ambiguous terms by examining context and matching them to real-world entities. For instance, it can determine whether Amazon refers to a global retailer or the Amazon River, and it links the text to external references like Wikipedia pages. Meanwhile, sentiment analysis evaluates emotional tone, not meaning. Key phrase extraction highlights topics but does not resolve ambiguity. And language detection simply identifies the language a sentence is written in without clarifying which entity a word refers to. Altogether, entity linking provides the precise disambiguation needed in content moderation systems. Question 34. Arrange the following steps in the correct sequence for adding a pre-built component to an entity in a conversational language model. Instruction. Drag and drop the items into the correct order, starting with the first step. Create an entity in your project. Select Add New Pre-built. Choose the type of pre-built component to detect. Save the updated entity configuration. Now that we've gone through the options and their correct sequence, let's move into the explanation. To begin with, you must create an entity in your project, because the entity serves as the container where all structured information is stored. Next, you select Add New Pre-built, which signals that you want to enhance this entity using predefined components provided by the platform. After that, you choose the type of pre-built component to detect, such as a date-time recognizer or number parser, depending on your model's needs. Finally, you save the updated entity configuration, ensuring the changes take effect so the model can automatically recognize and extract relevant information during conversations. This sequence mirrors how real conversational AI systems are configured in practice, where structured entities must be properly set up before they can interpret user input accurately. Question 35. A developer prepares a JSON payload for Azure AI language to classify documents. The body includes metadata, assets, and a field that tells the service which kind of operation to run. Which component ensures the service executes the intended classification? Select one answer. A. Enabling multilingual true. B. Setting the dataset field to execute. C. Using the project name as the operation identifier. D. Including the task specification within the JSON body. The correct answer is D. Including the task specification within the JSON body. Now that I've read the question, all the options, and the correct answer, let's move into the explanation. Including the task specification in the JSON body is essential because the service must know exactly which operation it needs to perform. The task type defines whether the model should run classification, extraction, summarization, or any other language capability. Without this explicit instruction, the service cannot determine the intended action. Moreover, using the project name as the operation identifier only provides descriptive labeling and does not instruct the system on what task to execute. Likewise, the dataset field simply indicates whether documents are meant for training or testing, rather than controlling execution. And while multilingual true enables additional language support, it has no influence over task execution. Consequently, only the task specification ensures that Azure AI language performs the correct classification task as intended. Question 36. For each statement below, indicate whether it is true or false. Multimodal models in Azure AI Foundry can handle both text and audio input. True. Deploying a multimodal model is only necessary when processing images. False. The Azure AI Foundry chat playground allows users to upload or record audio files for testing. True. Microsoft 5.4 Multimodal Instruct is a text-only model. False. Now that I've read the question, all the statements, and their correct true or false classifications, let's move into the explanation. Multimodal models in Azure AI Foundry are designed to work with multiple input types, so they can indeed process both text and audio. This makes the first statement true, because multimodal systems are built specifically for richer interactions that go beyond text alone. Next, deployment is not tied exclusively to image processing. Instead, deployment becomes necessary anytime your model needs to handle non-text inputs, such as audio. Therefore, the second statement is false, since it incorrectly narrows deployment requirements to images only. Additionally, the Azure AI Foundry chat playground genuinely supports audio interaction. Users can upload or record audio directly in the interface to test how their multimodal models respond. That makes the third statement true. Finally, Microsoft 5.4 Multimodal Instruct is not a text-only model. It is specifically designed to handle multimodal tasks, meaning it works with multiple input types rather than just text. Hence, the fourth statement is false. This completes the explanation of all four classifications. Question 37. For each statement below, indicate whether it is true or false. The Voice Live API supports both speech-to-text and text-to-speech capabilities. True. JSON-formatted events control conversations and responses between the client and server. True. The API key connection header can be used in browser environments. False. Avatar integration relies on WebRTC for real-time video and animation streaming. Now that I've read the question and all the answer choices along with their correct classifications, let's move into the explanation. To begin, the Voice Live API supports bidirectional communication, which means it can convert speech to text and generate speech from text. This makes the first statement true because it covers both directions of voice interaction commonly used in conversational applications. Additionally, JSON-formatted events play a crucial role in managing communication between the client and server. They define how sessions behave, how messages are exchanged, and how the conversation flow is controlled. That is why the second statement is also true. However, the API key connection header cannot be used directly in browser environments. Browsers block this type of header for security reasons, since exposing an API key in client-side code would create vulnerabilities. Consequently, the third statement is false. Finally, Avatar integration relies heavily on WebRTC technology. WebRTC enables real-time streaming with low latency, making it ideal for animations, lip syncing, and visual interactions. This is why the fourth statement is true. And that wraps up the explanation for question 37. Question 38. A home automation developer is training a conversational model that controls multiple smart devices. The phrases, "turn off the bedroom fan" and "switch off the television" are producing incorrect intent predictions. What is the most effective way to improve model accuracy? Select one answer. A. Rename all intents to generic terms like device action. B. Remove entity labels from all training data. C. Add more random utterances without structure. D. Define distinct utterance patterns for each intent, such as turning on, turning off, or checking status. The correct answer is D. Now that I've read the question and all the answer choices along with the correct one, let's move into the explanation. When a model confuses phrases like turn off the bedroom fan and switch off the television, it usually means the intents are too similar or lack clear structure. By defining distinct utterance patterns for each intent, the model learns consistent linguistic clues that separate actions like turning on, turning off, and checking status. This improves accuracy because the model can recognize patterns rather than relying on random variations. In contrast, adding random utterances without structure actually harms training, since the model loses consistent examples to learn from. Removing entity labels would also reduce accuracy because the system needs device-specific context to understand what is being controlled. And renaming intents to generic terms like device action removes the specificity required to distinguish different tasks. So defining structured, patterned utterances for each intent is what leads to cleaner training data and far more reliable predictions in home automation scenarios. Question 39. What is the primary purpose of using utterance patterns in a conversational language model? Select one answer. A. To automatically add punctuation to user phrases. B. To combine all utterances into a single generic intent. C. To help the model distinguish between similar utterances that represent different intents. D. To reduce the total number of intents required in the model. The correct answer is C. Now that I've read the question and all the answer choices, along with the correct one, let's move into the explanation. Utterance patterns are designed to help the model recognize important structural cues within language. By giving the model consistent phrasing templates, it becomes better at spotting subtle differences between similar-sounding user requests. For example, turn on the fan and turn off the fan share most of the same words, but the intent is completely different. Patterns highlight these distinctions so the model learns to separate them reliably. On the other hand, reducing the number of intents isn't the goal here. Patterns clarify differences. They don't eliminate intent categories. Similarly, combining all utterances into one generic intent would only reduce accuracy, not improve it. And punctuation isn't something the model automatically adds through patterns. It's simply part of the sample utterance examples you provide. So the real purpose of utterance patterns is to guide the model in distinguishing between similar utterances that point to different intents. Question 40. Each document entry inside the documents array of a classification project typically includes which fields? Select 3 answers. A. Location. B. Language. C. Dataset. D. Project kind. The correct answers are A. Location, B. Language, and C. Dataset. Now that we've gone through the options and the correct choices, let's move into the explanation. First, location is needed because the system must know where to find the text file or document, so this field usually stores a path or identifier that points to the content source. Next, language is essential, since the model has to know which language the document is written in, for example, EUN for English or FR for French, so it can apply the right language resources during training and prediction. In addition, dataset indicates whether that document belongs to the training set or the testing set, which is crucial when you are evaluating model performance versus feeding it learning examples. By contrast, project kind describes the overall project type, not properties of a single document, so it does not belong inside each entry in the documents array. Altogether, location, language, and dataset form the core metadata that allows the classification project to load documents correctly, interpret them in the right language, and treat them appropriately during training and evaluation. Question 41. A team uses the Azure AI Language REST API to train a model with an automatic data split. What happens during this training approach? Select one answer. A. The user manually assigns each document to the correct dataset. B. Azure divides all labeled data randomly into training and testing subsets based on defined percentages. C. All files are reserved for testing only. D. Azure ignores testing data and trains on all files. The correct answer is B. Azure divides all labeled data randomly into training and testing subsets based on defined percentages. Now that I've read the question and all the answer choices along with the correct one, let's move into the explanation. In an automatic data split workflow, Azure takes all the labeled documents you provide and uses your configured percentages to divide them into training and testing groups. This means the system handles the split for you, ensuring a fair and randomized distribution across both sets. Moreover, a manual assignment does not take place here, because manual splitting belongs to user-controlled dataset assignment, not the automatic mode. Likewise, not all files are used only for testing, since that would leave no data for the model to learn from. And Azure certainly does not ignore testing data, because the testing subset is essential for evaluating accuracy and preventing overfitting during the model building process. Overall, automatic splitting provides a clean, consistent, and randomized dataset division that supports reliable model training and evaluation. Question 42. Which option accurately describes phoneme usage in speech synthesis? Select one answer. A. It inserts a silence of specified strength. B. It specifies pronunciation using a phonetic alphabet and symbols. C. It changes the speaking style to excited for neural voices. D. It sets the document language for the entire SSML payload. The correct answer is B. It specifies pronunciation using a phonetic alphabet and symbols. Now that I've read the question and all the answer choices along with the correct one, let's move into the explanation. Phonemes are used in speech synthesis to precisely control how a word should be pronounced, and they rely on standardized phonetic alphabets such as IPA or XAMPA. This allows you to override default text-to-speech pronunciation whenever the automatic rendering may be inaccurate, especially for names, technical terms, or loanwords. Meanwhile, inserting silence refers to pauses, not phonemes, so option A does not describe phoneme usage. Likewise, changing the speaking style to excited is a neural voice style directive, which has nothing to do with phonetic pronunciation. And setting the document language applies to the SSML context overall, not to the specific pronunciation control that phonemes provide. Ultimately, phonemes serve one purpose: to tell the synthesizer exactly how each sound should be produced. Question 43. Which Azure portal can you use to provision an Azure AI language resource? Select one answer. A. Azure Policy Portal. B. Azure AI Foundry Portal. C. Azure DevOps Portal. D. Azure Data Explorer Portal. The correct answer is B. Azure AI Foundry Portal. Now that I've read the question and all the answer choices along with the correct one, let's move into the explanation. Provisioning an Azure AI language resource requires a portal designed specifically for creating and managing AI-related services, and that is exactly what the Azure AI Foundry portal provides. It gives users a centralized environment to set up, configure, and monitor AI resources, such as Azure AI Language, enabling text analysis, classification, and conversational models. In contrast, the Azure Policy Portal focuses on organizational compliance, so it cannot provision AI services. Similarly, Azure DevOps is intended for CI/CD pipelines and project management, not for creating cognitive resources. And Azure Data Explorer is used for querying and visualizing data, so it also cannot be used to deploy AI language capabilities. Therefore, the Azure AI Foundry portal is the only option equipped for provisioning Azure AI language resources. Question 44. Which statement best describes the relationship between Language Studio and the REST API? Select one answer. A. Language Studio requires the REST API to function. B. The REST API is limited to classification, not deployment. C. Both provide the same functionality for managing classification projects. D. Language Studio can train models, but the REST API cannot. The correct answer is C. Both provide the same functionality for managing classification projects. Now that I've read the question and all the answer choices along with the correct one, let's move into the explanation. Language Studio and the REST API are simply two different ways to interact with the same underlying AI language service. One provides a graphical interface, making it easier for users to create, train, and evaluate classification projects through a visual workflow. The other allows developers to perform those exact same actions programmatically using API calls. Consequently, both approaches have equal capabilities when it comes to managing classification projects, including setting up datasets, training models, and deploying them. They do not depend on each other, and neither is limited in functionality compared to the other. Therefore, the best description of their relationship is that they offer the same functionality, just through different interfaces. Question 45. You want to reuse labels created in another project. What constraint must be met when supplying the labels file to a new project? Select one answer. A. The file must store all text directly in the entities, labels, nodes. B. The file must include analysis time fields like display name and tasks. C. The file must use an accepted custom NER data format for import. D. The file must be in CSV with UTF-8 BOM. The correct answer is C. The file must use an accepted custom NER data format for import. Now that I've read the question and all the answer choices along with the correct one, let's move into the explanation. When importing labels into a new NER project, Azure AI Language requires the file to follow one of its officially supported custom NER data formats. This ensures the system can correctly interpret entity names, span offsets, and label structures without ambiguity. Other options may sound reasonable, but they do not meet the platform's requirements. For instance, storing raw text inside label nodes doesn't match how NER files are structured, and adding fields like display name or tasks applies to analysis requests, not label imports. Likewise, CSV with UTF-8 BOM is not a supported labeling format for NER projects. Therefore, only a properly structured, accepted custom NER data format can be imported successfully into a new project. Question 46. When developing a client application that communicates with Azure AI Speech through an SDK, which action must occur first in the code before making any API calls? Select one answer. A. Create a speech recognizer object to start listening. B. Instantiate a speech config object that holds the key and region information. C. Open the Azure portal to verify subscription usage. D. Define a transcription grammar file for input. The correct answer is B. Instantiate a speech config object that holds the key and region information. Now that I've read the question and all the answer choices along with the correct one, let's move into the explanation. Before any Azure AI speech operation can occur, the application must establish authentication and regional routing, and that is done by creating a speech config object first. This configuration object provides the subscription key and region, which the SDK requires to connect to the speech service. Only after the speech config exists can other components, such as a speech recognizer, be created. Likewise, verifying usage in the Azure portal is an administrative task, not part of application code. And grammar files are optional and used only in specialized recognition scenarios, so they are not required to begin making API calls. Question 47. A media team needs to extract specific fields from videos and documents in one pipeline, with custom logic that targets business-specific entities. Which service capability best fits? Select one answer. A. Azure AI Vision Object Detection. B. Azure AI Content Understanding with customizable analyzers. C. Azure AI Document Intelligence Pre-built Invoice Model. D. Azure AI Translator Glossaries. The correct answer is B. Azure AI Content Understanding with customizable analyzers. Now that I've read the question and all the answer choices along with the correct one, let's move into the explanation. This use case requires cross-modal extraction, meaning the system must pull structured information from both videos and documents in a single workflow. Azure AI Content Understanding is designed exactly for that, because it allows you to build customizable analyzers that work across text, images, audio, and video, while also letting you target very specific, business-defined fields. Meanwhile, Vision Object Detection only identifies visual objects and cannot extract structured fields or combine document and video intelligence. The pre-built invoice model is powerful for invoice data, but does not support multimodal extraction or custom entity logic across videos. And translator glossaries focus entirely on translation consistency, not field extraction. So the only capability that satisfies multimodal customizable field extraction is Azure AI Content Understanding with customizable analyzers. Question 48. Arrange the steps for implementing a facial recognition solution in Azure AI Vision in the correct order. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Capture or provide images containing faces. Train a recognition model with labeled faces. Use the recognition model to identify individuals in new images. Return identification results and confidence scores. Now that I've read the question and all the steps along with the correct sequence, let's move into the explanation. A facial recognition workflow always begins with gathering images that actually contain the faces you want the model to learn from. Once the data is collected, the next step is training a recognition model using labeled faces, so the system can associate each image with a known identity. After training, the model is ready to be applied to new images, where it analyzes the inputs and attempts to match individuals. Finally, the system returns identification results along with confidence scores, which indicate how certain the model is about each prediction. This sequence mirrors the natural logic of machine learning. Collect data, train, infer, and return outputs. Question 49. Fill in the blanks by selecting the correct options from the drop-down menus. To implement facial identification, you first create a person group, then add person records. For each individual, attach persisted faces from multiple images, and finally train the model. Now that I've read the question and all the correct selections, let's move into the explanation. When implementing facial identification with Azure's Face API, the process begins by creating a person group. This group acts as the container that will hold all individuals your system needs to identify. Next, you add person records, which represent each individual whose identity the model should learn. After that, you attach persisted faces from multiple images. Providing several images per person improves recognition accuracy because it captures variations in angle, lighting, and expression. Finally, you train the model, allowing the system to process all the stored faces and generate a recognition model that can later be used to identify individuals in new images. Question 50. For each portal capability, drag it to the description it enables. Each item may be used once, more than once, or not at all. Create a classification project and link it to a training resource. Correct match, project setup, and resource association. Upload images and assign class label tags. Correct match, image upload and tagging. Train and evaluate a model, then test it. Correct match, model training, evaluation, and testing. Publish the trained model to a prediction resource. Correct match, model publishing for inference. Now that we have read all the capabilities and their correct matches, let us move into the explanation. First, when you create a classification project and connect it to a training resource, you are really preparing the environment where the model will live. So this is clearly project setup and resource association. Next, once the project exists, you need data for the model to learn from. So the step where you upload images and assign class labels is exactly the image upload and tagging capability. It is all about getting labeled examples into the project. After that, the portal lets you run many training runs, inspect metrics, and try the model on test images, which is why training, evaluation, and testing match the description of training and evaluating a model, then testing it. Finally, when you are satisfied with performance, you push the trained model to a separate prediction resource so that applications can send it new images, and this is what we call model publishing for inference. Other options, such as setting pricing tiers for storage or configuring virtual networks, are important Azure tasks, but they sit outside the custom vision style portal workflow, so they do not match any of the listed portal capabilities here. Question 51. For each statement below, indicate whether the answer is true or false. Generative AI models can power chat-based applications that reason over user input. This statement is true. All multimodal models are limited to images and cannot process text. This statement is false. Some multimodal models include support for audio input. This statement is true. Azure AI Foundry is unrelated to building solutions that respond to user prompts. This statement is false. Now that I have gone through each statement and said whether it is true or false, let us move into the explanation. Firstly, generative AI models are often used as the brain of chat experiences. They read user messages, reason over that text, and then generate helpful responses, just like a support chatbot on a website or a coding assistant in an editor. Secondly, the idea of a multimodal model is that it can understand more than one kind of input, such as text and images together, so it is not limited to images only, and many of these models actually rely on text as a core input. Moreover, some multimodal families extend this even further and accept audio, which allows scenarios like uploading a voice note that is transcribed and then reasoned over alongside images or other content. Finally, Azure AI Foundry is very much about building and operating generative AI solutions that respond to prompts. so saying it is unrelated is incorrect. It is actually the place where you configure models, prompts, and safety settings to power those responsive applications. Question 52. Before using facial recognition in Azure Video Indexer, what prerequisite must be met? Select one answer. Option A. Optical character recognition must be enabled first. Option B. Limited access approval must be granted. Option C. It is automatically enabled for all subscriptions. Option D. It only functions with videos shorter than 5 minutes. The correct answer is B. Limited access approval must be granted. Now that I have read the question and all the options and chosen the correct one, let's move into the explanation. Firstly, facial recognition in Azure Video Indexer is treated as a regulated higher-risk capability, so Microsoft requires organizations to request limited access approval before they can turn it on. This process checks that you will use the feature in line with responsible AI and content safety policies, and only after that approval can the feature be used in your account. However, optical character recognition is a completely separate feature that reads on-screen text, so enabling OCR is not a prerequisite for face recognition. Moreover, the feature is not automatically enabled for every subscription, precisely because of those regulatory and ethical controls. Finally, there is no special rule that it only works on videos shorter than 5 minutes. Once limited access is granted, you can analyze longer videos too, as long as you stay within service limits and policies. Question 53. Your compliance team needs videos to identify internal project names such as OrchidX and Falcon 7, ensure those terms appear in transcripts, and also highlight mentions of your flagship product's name. What should you configure? A. Enable the predefined celebrity model only. B. Use only OCR for on-screen text, skip audio transcription. C. Use a custom people model and the celebrity model together. D. Train a custom language model and a custom brands model. The correct answer is D. Train a custom language model and a custom brands model. Now that I've read the question and the correct answer, let's move into the explanation. First, those internal project names like OrchidX and Falcon 7 are not part of standard vocabularies, so a custom language model is needed to learn and reliably recognize them in transcripts from your videos. Moreover, you also want to highlight mentions of your flagship product. For this, a custom brands model is ideal because it is designed specifically to detect and tag organization-specific brand and product names across the content. By contrast, the predefined celebrity model only helps recognize famous people's faces or names, which does nothing for internal project or product terminology. Similarly, using only OCR for on-screen text would miss spoken mentions in the audio track, and that would leave many critical references undetected. Finally, a custom people model focuses on identifying faces and individuals, not words, project names, or brands. So, configuring both a custom language model and a custom brands model together ensures your system can accurately transcribe internal project names and clearly highlight every mention of your flagship product across all video transcripts. Question 54. When working with a DALL-E model in the Azure AI Foundry Images Playground, which statement accurately describes how the model can be configured? A. You can choose between different resolutions, image styles, and quality levels before generation. B. You must retrain the model to support higher resolution outputs. C. DALL-E automatically generates all images in one fixed size and style. D. You can only control the prompt text. Other parameters are locked. The correct answer is A. You can choose between different resolutions, image styles, and quality levels before generation. Now that I've gone through the question and the correct answer, let's move into the explanation. In Azure AI Foundry's Images Playground, DALL-E models give users control over several configuration settings before generation. For example, you can adjust the resolution, select an artistic style, or change quality levels to influence the final output. Moreover, Retraining is not required because DALL-E models are already pre-trained and support these adjustments out of the box. Additionally, it's not true that images are always generated in a fixed size and style, since users can vary these settings directly in the interface. And contrary to option D, you're not limited to only editing the prompt. The playground exposes multiple adjustable visual parameters, making the generation process flexible and customizable. Therefore, being able to choose resolutions, styles, and quality settings before generating the images is what accurately describes how the model can be configured. Question 55. A finance department wants to pull invoice number, due date, and total amount from PDFs to speed up payment processing. What capability is most relevant? A. Extract specific field values from documents and forms. B. Route files through public internet proxies. C. Apply video activity detection to the PDFs. D. Use sentiment analysis on the invoice totals. The correct answer is A. Extract specific field values from documents and forms. Now that I've gone through the question and the correct answer, let's move into the explanation. Extracting structured information such as invoice numbers, dates, and totals requires a capability designed to read and interpret fields within documents and forms. Technologies like Azure AI Document Intelligence are built precisely for this purpose, allowing automated extraction of key value pairs from PDFs and scanned documents. Meanwhile, routing files through proxies doesn't extract data at all, and video activity detection has no relevance to static PDF invoices. Furthermore, sentiment analysis focuses on emotional tone or subjective text, which doesn't apply to numeric financial fields like totals or due dates. So the most appropriate capability is extracting specific structured field values from documents and forms to automate invoice processing. Question 56. Fill in the blanks by selecting the correct options from the drop-down menus. The Analyze document function starts the analysis using a custom model ID, and the output includes Analyze Result, which stores extracted text and page data. Now that I've read the question and the correct answers, let's move into the explanation. The Analyze document function is used whenever you want to run inference on a document using Azure AI Document Intelligence. It triggers the analysis pipeline and processes the file you submit. Next, specifying a custom model ID tells the service exactly which trained model should handle the document, ensuring the correct extraction logic is applied. Finally, the service returns Analyze Result, a structured response that contains extracted text, tables, key value pairs, metadata, and page-level details. This is the core output your application uses to work with the Analyze document. Altogether, these components work together to run a complete document analysis workflow efficiently and accurately. Question 57. For each indexing concept, drag it to the appropriate description in the correct match column. Extracts and indexes data fields from the data source automatically. Indexer. Performs document cracking and applies enrichment pipeline steps. Enrichment pipeline defines the searchable content created from the processed documents. Index contains enriched and hierarchical data fields ready for querying. Index document. Now that I've read the question and all the correct matches, let's move into the explanation. First, the indexer is the component that automatically extracts fields from your data source and feeds them into the index. Without it, there is no structured content to search through. Next, the enrichment pipeline runs document cracking, skill execution, and any transformations you configure. This is where AI-based processing such as entity extraction or OCR takes place before the data is stored. After that, we have the index itself. This is the searchable structure that stores fields created by the indexer, enabling fast lookup and querying across your documents. Finally, the index document represents the enriched, structured JSON output produced after the pipeline finishes. It becomes the query-ready entity combining both raw and enriched fields. Together, these components form the full life cycle of indexing: extraction, enrichment, indexing, and structured output, ready for search. Question 58. For each statement below, indicate whether the answer is true or false. The indexer extracts content from the data source and populates the index automatically. True. Each skill in the enrichment pipeline removes fields from the document after processing. False. Image data must be normalized before being used as input for image processing skills. True. Fields created by skills must be explicitly mapped to target fields in the index. Now that I've read the question and all the correct answers, let's move into the explanation. First, the indexer truly does extract content from the data source and automatically fills the index, because that's its primary job in the Azure Cognitive Search pipeline. It reads, processes, and populates searchable content without manual intervention. Next, the statement about skills removing fields is false. Skills enrich data by adding new information, not by deleting existing fields. They enhance the content so the index includes more searchable insights. Then, when it comes to image processing skills, normalization is indeed required. This ensures the image format and structure are consistent, allowing each skill to function correctly and avoid errors. Finally, fields created by enrichment skills must be mapped to target index fields. This explicit mapping ensures enriched data lands in the correct place for querying and retrieval. Without mapping, the index wouldn't know where to store each enriched value. Question 59. Arrange the following steps involved in calling a document analysis model from code in the correct order. Instruction: drag and drop the items into the correct order, starting with the first step at the top. First, obtain the service endpoint and API key from the portal. Next, create a client and authenticate using the endpoint and key. Then, submit the document to the chosen pre-built model for analysis. After that, await completion and retrieve the analysis result. Finally, parse the returned fields and values for application use. Now that I've read the question and all the correct answers, let's move into the explanation. To begin, the very first thing any application must do is obtain the service endpoint and API key, because without credentials, no request to Azure AI services can be authenticated. Once those values are available, the application can create a client and authenticate using the provided endpoint and key. This establishes a secure connection and prepares the environment for sending requests. After authentication, the client can submit the document to the chosen pre-built model for analysis. For example, this might be an invoice model, a receipts model, or any custom-trained option. Since document analysis can take several seconds, the application must then await completion and retrieve the analysis result. This ensures that the returned information is complete and ready for processing. Finally, once the results are retrieved, the application parses the returned fields and values for application use, such as extracting totals, dates, names, or other structured outputs needed for downstream workflows. This creates a smooth end-to-end flow from authentication all the way to usable data. Question 60. Which additional functionalities can be enabled in content understanding schemas for certain content types? Select two answers. A. Extracting barcodes from text in documents. B. Compressing file storage automatically. C. Generating color palettes from images. D. Recognizing mathematical formulae in text. The correct answers are A. Extracting barcodes from text in documents, and D. Recognizing mathematical formulae in text. Now that I've read the question and the correct answers, let's move into the explanation. To start, extracting barcodes from text in documents is a capability offered in specific content understanding schemas. Because some schema templates are designed to detect structured identifiers like QR codes or barcodes directly within document layouts. This makes it useful for processing items such as shipping labels, product packaging, or inventory forms. Moreover, recognizing mathematical formulae in text is another supported enhancement. Since certain templates include built-in logic for detecting LaTeX-style expressions or structured math notation within textbooks, academic papers, or engineering documents. This enables downstream applications to categorize, index, or further analyze technical content with greater precision. However, compressing file storage automatically is not part of schema capabilities, because storage optimization is handled by platform-level infrastructure, not content schemas. Likewise, generating color palettes from images is unrelated to content understanding, as it falls under image analysis scenarios focused on visual interpretation rather than document structure. Together, the correct capabilities support advanced text interpretation and structured data extraction, enhancing the intelligence of document-centric workflows.